whole summer there, half the winter maybe.
Yeah. So much to see in this world, so much to do.
Yes.
And I think maybe the one good thing about this whole situation that we're all in is that we're returning to meaningful travel, and that we're learning maybe a lesson on what are our values, what do we want out of life. And maybe it's good that we're all kind of like had to stop, including traveling and including go learn. And when we return, we hopefully go back with a heightened sense of awareness of how amazing this globe and just the fact that we can travel is. So we're super lucky. And if we're returning, if the Europeans let us come back.
Right. Right now they don't want us.
Yeah, we're the dirty people right now. Yeah. But I think we will be able to do that.
Yes.
So, Holly, the room is full.
Okay.
It's 12:01. I'm going to start. Everyone out there, this is Go Learn at the University of Utah. If you have joined us before, you know the spiel. One of our professors who possibly takes us on trips will present on a topic of passion. Today, it's Holly Godsey from the College of Mines and Earth Sciences, Department of Geology and Geophysics. Again, that's a mouthful. And Holly has, I looked up her CV, is 12 pages long, including publications, including all her wonderful degrees, including a Bachelor of Science, cum laude, from us, the University of Utah. Where was your master's from again?
University of Michigan.
University of Michigan, and then a PhD from the University of Utah. Mm-hmm. So it doesn't get more, I don't know, homegrown than this. A quick shout out, if people join us who are new to us, if you're an alumni, hello and welcome. This is also brought to you by the Alumni Association. I always want to mention these guys who are doing a great work here. And we have alumni out, of course, worldwide. And so hopefully someone out there from the East or West Coast or even beyond is joining us today. Yeah, let's get started. As how this will work is I will kind of like leave the room and Holly has the floor. There is, for everyone out there, if you're new to this, there's a question, answer, and a chat. Either one of them, send us your questions. The webinar works that we can't just immediately intervene and have these questions out there, but I will get to them at the end of our presentation. And hopefully we will learn a lot about Iceland today and the geology. And, you know, I heard Holly said she will, you know, quote unquote, this is my word, geek out on us for about a few slides on geology, but also to introduce us to this fantastic destination to which we were lucky to travel in 2018 and 17?
18 and 19.
18 and 19, that's right. So thank you very much, everyone, for joining us today. I'll just be in the background here, but you won't see me. And Holly, it's all yours. Thank you.
Okay, thank you, Christoph. Hello, everybody, and thank you for joining us today. I'm going to just share my screen here real quick, get this going. Okay, Christoph, will you let me know if there's any problems with the graphics that come up from your end?
You're totally fine.
I'm totally fine. Okay, that's great. Okay, so as Christoph mentioned, I'm Dr. Holly Godsey. I'm from the Department of Geology and Geophysics at the University of Utah. And today, what I'd like to talk to you about is probably my favorite place on the planet, the country of Iceland, and specifically about the geology of Iceland. So this is just an absolutely spectacular place that just holds some really unique features that you can't see anywhere else in the world. And so I'm really excited to share this with you. So we're going to talk about the geology. We're also going to talk a little bit about the biodiversity, some of the ecology, Iceland's potential for sustainable energy, which is really quite impressive. A tiny little bit about the human history. And if we have time, we're also going to talk about how Iceland has some of the very best, but also some of the very worst food in the world. So And as Christoph mentioned, we can't take questions during the actual webinar, but I'll be happy to answer anything afterwards. Okay, let me see if I can get my controls working here. There's 1 second. Okay, so Iceland, it's known as the land of fire and ice, and I really love this picture. Just a beautiful depiction of the countryside itself. This is actually Mount Kirkjubel, which is basically means church mountain. And this is the mountain that was used as the model for the little postcard that Christoph held up at the very beginning of the broadcast. So Iceland's known as the land of fire and ice because of all of the volcanic activity and all of the glacial features on the land. But I do want to point out, and this picture shows it very well, that one of the most remarkable features there is all of the water. And it's the interactions of the water with the rock that really help make the scenery so spectacular, either through waterfalls like you see here, or in lakes and streams, and just carving really beautiful valleys. And even all of the water is responsible for turning what would otherwise be very black volcanic landscape into this lush, green, beautiful, mossy meadows. And so the first time I went to Iceland, the thing that struck me and stayed with me is how vibrant the colors are. It's just remarkable. And those of you that are from Utah and have been to and from Utah in July, you know that to go to some place like this in July and then come back to Utah is a little bit of a shock. We love Utah, it's gorgeous, but it's definitely not green. So I want to start off with talking a little bit about some basics. As you can see, Iceland is located right here in the North Atlantic Ocean between Greenland and Norway. And it sits at a latitude at about 64 degrees north. I say about. So it's just below the Arctic Circle, which is about 66.5 degrees north. And so very, very northern tip of Iceland just barely crosses over the Arctic Circle. So its population is 364,000, give or take a few, which is about the size of the population in the Salt Lake Valley. So that's kind of Salt Lake City proper and West Valley, again, for locals who understand the region. And it has a land area of about 103,000 square kilometers. Again, for a comparison, it's smaller than the state of Utah. It's about the size of Kentucky or Virginia, if that kind of helps you kind of get an understanding. Now, the official language is Icelandic, but thankfully for me, everybody there, almost everybody there speaks English. Icelandic is an incredibly difficult language to learn and to speak, at least for me. I have a really hard time hearing the sounds and so forth. And so I'm going to apologize in advance for mangling some of the Icelandic words. So what we know about the earliest settlers in Iceland comes from something called the Landnámabók, which basically translates to the Book of Settlements. And this is a really impressive medieval manuscript that tells the story of how the Norsemen coming from Norway explored and settled this country. So you can see in this map in the upper corner here, these are routes that the Vikings took when they were traveling around the area in the 9th century. This even includes the route of Leif Erikson as he was going on his way to actually discover North America. So despite all the Viking voyages, the first person to consider to be a settler in Iceland is Ingolfur Arnason. So he sailed to Iceland and he landed right about here, sort of on the very northern tip. And legend has it that when he arrived there, he threw his oars overboard and he said, wherever these oars wash ashore, that's where I'm going to build my home. Well, they didn't find the oars for 3 years. And when they did, it was to the north and west near the area of Reykjavik, where he actually did end up settling. But in the next 45 years or so, anywhere from 10 to 20,000 people came over from Norway, from Scotland, and Ireland, and settled on the small island here. Now, most of the people, when they think about Icelandic people, they think of Vikings. So kind of the traditional idea of Vikings, where they're the seafaring pirates and tradesmen. But really, these people were mostly fleeing the Vikings. I mean, they were essentially fleeing the tyranny of Harald the Fair-Headed of Norway, who was trying to unite all of the tribes, and actually was successful at that. But these people were really trying to kind of get away from sort of that influence, that overpowering influence there. So one of the first things that people notice when they get to Iceland is this lack of trees on the landscape. And it's really something that is not actually a natural feature of the island. And when the settlers first arrived here, about 40% of the country was covered with trees. And so what you see now are just a few groves of sort of scrubby birch trees, and maybe some willows, mostly just shrubs around. And so the question is, well, what happened to all the trees? Well, when the settlers arrived, they needed wood for their houses and for keeping warm and building their ships and so forth. And so they started cutting down trees. They also brought with them all sorts of domestic livestock like sheep and cattle and horses, that when a sapling would start to grow, they would nibble it down to the point where it couldn't survive. So that was a bit of a problem, but it was very much compounded by the geology of the land as well. The first thing that really kind of affected this is the fact that that Iceland is a very young island, geologically speaking. So the lava flows that began erupting that formed Iceland about 25 million years ago, and really the oldest rocks on the island are only 18 million years old. And geologically speaking, that's very young. What that means is that there hasn't been enough time for the rocks to break down and form a nice thick soil layer. So the soil is very thin. There's also a lot of lava flows and ash falls that tend to cover over any land that's arable in the region. The fact that you have this hot volcanic activity also makes the ground too hot in some places for trees to take root. And there's some harsh climate conditions. You add to that the massive erosion. Remember, we talk about the land of ice, and also all that water. And again, you're just really not setting up a good environment for growing trees. And so it only took about 300 years for these settlers to deforest almost the entire country. And so you went from 40% tree coverage to about 1% tree coverage. So this became a problem for a number of reasons. And Iceland, about 100 years ago, started some revegetation efforts. And one of those efforts was bringing back native plants and trees from Alaska, and seeing if they could take root here in Iceland. So these beautiful lupins that you see here in this picture are everywhere across the country. And lupins are really unique in the sense that they grow pretty well in poor soil. They don't need a lot of soil depth. They take root in these places pretty easily. They're also nitrogen fixers, which means that they are helping replenish the soil that they're in, and they help prevent erosion. So it sounds like a really great thing to start revegetating this country with these lupins, to start laying sort of the groundwork for other plants to come in. Well, the downside of this is it turns out that lupins are invasive. And so when we're standing there, we're looking across these beautiful lupin fields and thinking, wow, these are so beautiful. They're in the process of killing off all of the native vegetation that does exist. So all of the berry plants and the shrubs and any of the native trees that are trying to take root. So Iceland now has a different problem. I also want to talk a little bit about the animals in terms of the ecology. So there's only one land mammal that's native to Iceland, and that's the Arctic fox. You can see that guy right here. there were no native mice or rodents or anything on the island. And the ones that exist there now have come over with humans. There's a lot of native marine mammals, such as whales and seals. And then there's a large population of seabirds. And the most famous is probably this cute little guy here, the puffin. And Iceland has the largest colonies of puffin in the world. So it holds about 60% of the world's puffin population. So some of the domestic animals that they brought over are the Icelandic horse, which is unique in that it has a small stature that you can see here. And they're also very intelligent animals. And so Iceland's been really protective about this breed. They don't allow any of these horses that have left the island to actually come back. And they don't allow anybody to bring over any other breed of horse. Iceland's also known for its sheep and its wool products. Sheep do very well in Iceland in the harsh climates and enjoy all of the grass that you see there. So the one thing that Iceland doesn't have are mosquitoes, which is amazing when you think about all of that water. And the neighboring country over Greenland is full of mosquitoes. And the reason for this is that the climate conditions are so variable in Iceland that the mosquito does not have time to complete a full life cycle. And so it's pretty amazing that you can be in all these places with all this water and not have to worry about this. Now, with climate change, that might change, because if the climate becomes warmer and more consistent, or at least more consistently warmer, mosquitoes might be able to take hold in this country. What we're really here to talk about today, though, is Iceland's unique and just absolutely beautiful landscapes. So everything from sort of these moss-covered lava fields and rocky coastlines to the glacial-capped volcanoes that you see here, to these glacier-filled valleys, and these powerful waterfalls that pretty much are ubiquitous throughout the country. All of this stuff is so unique and so uniquely beautiful and looks unlike any other place that I've been to on the planet. And the question then becomes, well, why does Iceland have all these unique features? And the answer lies in the geology of the land. And so the geologist is responsible for almost everything that you see there, at least from the perspective of a geologist, that is. So the processes that have been happening in there have been occurring for about the last 25 million years. And what we see is the result of all of these geologic actions over that period of time. So I'm going to back up for just a minute. And I think in order for us to really understand sort of the uniqueness of the geologic phenomena in Iceland, we have to understand a little bit of basics. And so I'm going to give you a sort of a compressed full semester of geology in like 6 slides. So if you know all this, bear with me. If you don't, I hope you find it interesting. So just the fundamental premise of the plate tectonics theory is that the planet of the Earth, the surface of the Earth, is made up of rigid plates, interlocking plates that are outlined here in red, that fit together like puzzle pieces. And these plates actually move with respect to one another. So they can either move together like you see here on the South American plate and the Nazca plate. They can slide past one another. This is evidenced by the San Andreas Fault in California. Or they can move away from each other. They can diverge. And this is the situation that we have near Iceland. So this is a schematic cross-section of the Earth showing all of these major plate motions. Again, the plates moving past each other, they're either moving away from each other or they're moving toward each other. And there's a lot of information in this diagram, so I really want us just to focus on the few pieces that are relevant to the geology of Iceland. And so if you look down here, there's this divergent plate boundary, which means moving apart. And it's evidenced by this, what is called an oceanic spreading ridge. So it's like this little mountain range big mountain range under the water, and it's actually moving apart. And right down the center of the ridge is this valley. And this is a place where hot stuff from the interior of the earth, rock moves upward. And as it gets closer to the surface, it begins to melt. That's what's shown here by all these little red speckles in here. And it erupts into this fissure as volcanoes, and erupts lava onto the surface of the ocean floor, of the seafloor here. The other thing that I think is really important to understand about Iceland, and we're going to talk about more in a minute, is this thing called a hotspot. So a hotspot is a place deep in the earth where there is sort of a plume of hot material that is rising toward the surface. And as it rises, it actually burns a hole through these rigid plates we call these also the lithosphere. And then can form, often forms volcanoes above the position of the hotspot. Now, it's important to notice that the plates move away from the ridge, but the ridge can also move if there's an overall plate motion in a certain direction. The hotspots, on the other hand, stay in the same place. They are fixed in place, but the plates move over them. And so this is just a close-up depiction of what a hotspot looks like. Again, you sort of have this rising plume. Here's the plate. It's moving over the hotspot. And as it does so, you see that there's all of these enormous, we call them flood basalts. It's basically lava that pours out onto the ocean floor. And oftentimes what happens is as the plate moves over the hotspot, you leave behind this trail of volcanoes. And some of you might recognize this pattern if you've been to Hawaii or know anything about the formation of Hawaii. It's very much the same process. And also the same thing that's happening as the plates are moving over the Yellowstone hotspot. So it doesn't have to be in the ocean. It can be anywhere on the earth. Iceland sits on top of one of these mid-ocean ridges. So that oceanic ridge that we saw. And that's part of what makes it so unique. And so again, you can see here's where the magma is coming up from deep under the earth. Magma is basically just molten hot rock. It becomes lava. We call it lava once it exudes out onto the surface. These plates are moving apart here, and the magma is filling this fissure here. And here's Iceland that sits right on top of this mid-ocean ridge. So the question is, why doesn't this happen everywhere along the mid-ocean ridge? Why don't we have dry land sitting on top of the mid-ocean ridge in other places where these things occur? And the answer is that not only does it sit on top of a mid-ocean ridge, but it also sits on top of what's called a hotspot. So this is pretty impressive. So if you take a look here, we have this, again, this is an outline of the island. And what you see here is this rising mantle plume, and then the hotspot is located about right there, kind of in the south center area of the country. This white region that you see right here is the Vestmannaeyjar Glacier, largest glacier in the country. And that's just kind of for reference. And then the other important thing to notice is this sort of green shaded area, which is the expression of the mid-ocean ridge underneath Iceland. And as you can see, it's not just this straight line like we've depicted in the schematics, but it's really kind of bifurcated. It's kind of splintered off in these two little forks here. And I kind of want you to keep this image in your head as we move on and talk about some of the volcanic activity in the region. So we've got this hotspot, we've got this mid-ocean ridge, and this hotspot provides so much more hot material underneath the ridge that it pushes the land up above the surface of the ocean. This is absolutely amazing. And so we've got volcanic activity from the ridge, we've got volcanic activity from the hotspot, what you end up with is with this massive land that's actually sitting above the surface of the ocean. This is actually a pretty unique thing. And this is one of the only places on the planet where you can see a mid-ocean ridge on dry land. So a lot of this can be evidenced when you look at this map of the seafloor. This is the topography of the seafloor. Basically, it's like a relief map is what you're looking at. And here's Greenland, and you can see Iceland right here. And the thing that is most noticeable about this map is this really long, sort of roughly north-south running suture-looking thing, which is the mid-ocean ridge. The formal name for this is the Mid-Atlantic Ridge. But you can see this runs almost from pole to pole. It is the longest mountain chain in the world. This is basically these underwater mountains have a relief of up to 10,000 feet. But all of it, almost all of it, is underneath the water, except for in this region where Iceland lies. And you can also see this high plateau right here, which is the underwater part of these basalts, this magma or lava that has flown out of the volcanoes and the hotspot and formed sort of the base of Iceland. Okay, this is where things get really cool. So this is Þingvellir National Park, and I should say a little something about Icelandic characters. This kind of funny looking P is actually pronounced TH, so a th. And then when you have two L's together, sometimes it has a little T or D sound, but sometimes it doesn't. But anyway, this is pronounced Þingvellir National Park. And this is, like I mentioned, one of the only places in the world where you can actually see the evidence of this mid-ocean ridge on dry land. And so this place is so cool. And it's one of the first stops that we do on our Go Loon trip. And so what you see here is this really long faults that run along here. And then there's some fissures. Fissures are basically just cracks. They don't have any faulting or displacement along them. And then this broad valley here, which makes up something called a graben. And if you look in the diagram here in the lower corner, these are all faults that are normal faults, which basically means we have one block that's dropped down relative to the other. And in the case here, the graben is bounded on both sides by faults, forming this valley here. And so this is what we're seeing at Þingvellir National Park. And it's basically the extension. This whole region is part of that mid-ocean ridge that has been pushed up onto dry land. Here's a couple more pictures of Þingvellir because it's just a remarkable place. Here are folks walking down in between the fault, along the fault line there. This is looking out across the graben. Iceland's biggest lake is located in this area, obviously because there's this big down drop area and water likes to flow downhill. In these fissures, this color of this water is just spectacular. So this water is all glacial fed, so it comes from a glacier, and it takes about 300 years to come from the glacier and filter down through all this basalt rock before it reaches this area. And as it's moving through the rock, all of the sediments and impurities get filtered out of it. So this is the purest water in the world right here, so clean and crystal clear. And you can see here, you can actually scuba dive in some of these fissures. This is called Silfra. And this person here is putting one hand on the North American plate and another hand on the Eurasian plate, which I just think is the coolest thing in the world to be able to do that. I mean, he's got to feel like really powerful and amazing at that point that's happening. So I also need to throw in a little bit here about the historical significance of this area. So not only is it super cool geologically speaking, but the history is pretty impressive there as well. So Þingvellir is the location of the oldest surviving parliament in the world. And so this parliament was formed in 930 AD. And this is where all of the tribes from all of the islands would come together to make laws, to make proclamations, to dole out punishments and so forth. And you could see they built these structures because they were there for a couple weeks. And you can actually still see the foundations of these structures when you walk through that fault valley there. There's a person up here that's standing on this rock. It's called the Law Rock. And apparently the acoustics of these cliffs made it just a perfect place to stand up there and talk to large masses of people. So back to talking to the mid-ocean ridge. Again, the formal name is the Mid-Atlantic Ridge. So I might kind of go back and forth between those two words right there. Here again is the trace in the dark yellow through the country of Iceland. And you can see the bifurcation where it kind of splits a little bit. All of these little triangles that you see here represent the location of some of the bigger volcanoes in Iceland. And you can see that they pretty much correlate with the location of the Mid-Atlantic Ridge, which makes a lot of sense. These are technically all active volcanoes. There is an eruption in Iceland about every 4 to 6 years. So there's never a dull moment there in this country when it comes to volcanic activity. So many of you might remember the Eyjafjallajökull eruption of 2010. So this is 10 years ago. This was a relatively small, as far as volcanic eruptions go, this was relatively small, but it caused enormous disruption to the airspace over Iceland and most of Northern Europe. So it disrupted like 10 million travelers. Airplanes were grounded for about anywhere from 2 to 6 weeks, depending on where you were. And so it was really a big mess in terms of travel and so forth. And I actually remember seeing pictures of this erupting on the TV. And it was so funny because every time a TV newscaster would try to say the name of the volcano, they would say it differently. And I have had the same problem as well, because you can see it's a little bit of a challenge. But one of the locals taught me that the best way to remember this is to think, I forgot my yogurt. So it's Eyjafjallajökull, but if you say I forgot my yogurt, people will know what you're talking about for the most part. So anyway, the reason why this volcano was so destructive is that it sits right underneath the jet stream. And at the time of the eruption, the jet stream was pretty stable, more stable than it usually is. And so things were just they were getting concentrated and they just weren't able to get dispersed in a way that they normally would. The other thing is that the eruption began to melt the ice. You can see a little bit of this ice cap here that sits right on top of the volcano. And that water flowed back down into the volcano. It was heated, it flashed to steam, which caused the volcanic eruption to be even bigger. And this is a satellite photo of this gas and ash cloud that was getting shot right up into the atmosphere, into the jet stream. The other thing that happens is when the lava from the eruption got into the cold water, it cooled off immediately. And what happens is that it just shatters. So it goes from this hot molten rock and it hits this cold water, and then it just shatters into glass shards and ash. And again, that was part of what made up this cloud that shot up into the atmosphere. And this was clogging up airplane engines and causing all kinds of havoc. So the other really important thing about this eruption is that this pretty much signaled the start of the tourism boom in Iceland. So really only 10 years ago. Before that, Iceland had tourism, but nothing to the extent of what happened after this eruption. People were seeing pictures of the beautiful countryside and decided they wanted to go there and see what this place is all about. So in 10 years time, and I would even say less than that, it went from a country, with a population of a little over 300,000 to a place where the population increased fivefold in the summer. They did not have the infrastructure, and still do not have the infrastructure to deal with this kind of tourism. There are no hotels, the public restrooms didn't exist. There were no trails or trail signage, that kind of thing. And so Iceland is really struggling to deal with the massive amounts of people that are coming into the country. And it has really been a boon to the economy, but at the same time, it's been pretty destructive to the environment as well. And so that's what's really great about the Go Learn trips, is that we really take small groups of people and we try to keep ourselves very contained and really try to be mindful of how we're treating the land and the environment there. So there are some geologic phenomena that are so common in Iceland that they have their own terms that have been recognized internationally by geologists. This term up here is a jökulhlaup, and a jökulhlaup is essentially a flood that occurs when a lake that sits under a glacier sort of breaches its dam. And so you can see that here's this glacial ice cap, and underneath it was some water, and it busted through the dam that was probably located about here, and this whole ice cap collapsed. That in and of itself is not that much of a problem, but what is the problem is all of the water that flows out of that is really sediment laden. It's full of all kinds of debris and is so powerful. It can knock out just about any structure. And this picture that you see here in the lower left is a remnant of a bridge that they built to complete the road that encircles Iceland. They finally used to have to drive almost all the way to around the country, and then you had to drive all the way back because the road wasn't connected. And they finally connected it in 1974. And then in 1998, they had this enormous jökulhlaup and destroyed the bridge. And so they had to rebuild it again. All of this glacial outwash is called sander in Icelandic. So this is called a sander plain. But it also does these things like create these beautiful carved canyons that you can see here as well. This is Katla. This is another volcano. You can see this diagram down here with its relationship to Eyjafjallajökull. I show this because this is Eyjafjallajökull. Here is the magma chamber that fed the volcano. This blue is a little bit of the ice sheet on top that caused all the problems with the ash and being shot into the atmosphere. Well, Katla sits not too far from there, and it's got an even bigger magma chamber and an even bigger ice cap that you can see sitting on top of the volcano there. And there have been some rumblings in recent years around Katla. The way 2020 is going, this may be the year, but could be some really significant issues if Katla blows its top anytime soon. So I share this picture of Heimaey Island. This is an island off the coast, the south coast of Iceland. It's on the Vestmannaeyjar archipelago. And this is just a remarkable place. We spent a couple days at this place on our trip because it's just got so many things, unique things to see. But this is the little town of Vestmannaeyjar. It has a population of roughly 5,000 people. And here you can see this sort of dark reddish brown area. This is all fairly new land on the island. This is Eldfell volcano. This is an older volcano over here. But the Eldfell volcano erupted and all of this lava spewed out here into this harbor. And this is the harbor entry into the town. This is a fishing village essentially. And so the harbor is pretty critical to the island. So the story goes that in 1973, Eldfell in January erupted in the middle of the night. And so this was a fissure that nobody even knew existed at the time. And it started erupting in the middle of the night, and they had to evacuate the entire town in a matter of hours, which they successfully did. So it's this fissure was less than a mile. In fact, it's kind of in the backyards of a lot of these houses here. And you can see it just it erupted for about 6 months, and it just deposited all of this hot ash and cinder over the whole town. This is a picture here of the cemetery in town, which had to be dug out by hand because they couldn't bring in bulldozers or they would knock over all of the gravestones. And the scariest thing about the eruption, well, one of the most destructive things is that all of that lava, like I mentioned in this last picture, was flowing toward the harbor. And you can see here what they tried to do, because if that lava closed off the harbor, it would essentially spell death to the island population there. They actually fought it off with fire hoses, and they were successful. So it's a pretty amazing thing. You can still see remnants of these houses that are buried, many of them up past the roofs and so forth, as you walk around just right outside of town. And there's a wonderful museum there that tells the whole story. Another eruption that occurred off the southern part of Heimaey Island is the Surtsey eruption of 1963. And I remember hearing about this as a kid, and for some reason it just absolutely fascinated me. But it was an opportunity for the world to witness the growth of an island for the very first time. So it began erupting, and over time it built up this cone larger and larger until it finally breached the surface of the ocean. And by the time it was done erupting, it had it was about a mile square in surface area. It's since kind of been eroded a little bit, and also kind of contracted. The hot rocks kind of contracted and it sunk down a little bit. But it's really just an amazing thing. And you can take a boat ride to Surtsey, but you can't actually set foot on it because researchers and scientists are using this as a place to study how brand new land is colonized by plants for the very first time, which is super cool. But they don't want anybody coming, with microbes or seeds or whatever on their shoes and walking all over this. And so you can't actually step on the island unless you have special permission. Okay, so with all of this lava, or all this volcanic activity, you can imagine there's just lava flows everywhere. The lava is mostly what we call basaltic in composition. That just is, it's a descriptor that means it has a certain mineral composition, mostly dark minerals. And sometimes when lava cools, it takes on these really crazy, unique shapes. And many of you may have seen this kind of thing before, but they're called columnar basalts. And they're these long, sort of spiky basaltic columns that you see here. And these are all over the country. And the way this happens is that when lava flows out onto the cool surface, as it starts to cool, it actually begins to contract. So, things pull in together, and it does this in a pretty regular pattern. The most efficient way to do this is kind of in this hexagonal shape that you see here, and you can see in these sizes here. Whoops, apologize. And so what happens is that it cools from whatever the cooling surface is, and those cracks just propagate on down as the lava cools and solidifies through the lava flow. And so you end up with these long columns and these stacked plates that make up these columnar basalts. Now, the crazy thing is if the lava flows out and it interacts with a cold surface that isn't flat, so something that's vertical, maybe like a canyon wall, or maybe it flows in under a great glacier, then these columns form perpendicular to whatever that cooling surface is. And so they get crazy shapes like you see down here, and they can be all twisty and turny and going every which directions. And it's just an absolutely bizarre landscape that you see everywhere in Iceland. So here's a few more of those columnar basalts. This is at a place called Reynisfjara. This is a world famous black sand beach, not just because of black sand, but also because of these gorgeous sea stacks that you see off the coast. We have some of our Go Learn travelers taking advantage of all these little columnar basalts here. But black sand beaches are pretty rare relatively speaking. When you think about a beach, you're usually thinking about something that's kind of white or tan sand, but there are a few black sand beaches that occur in the world. Now in Iceland, they're the rule rather than the exception. And the reason for this is because of the constant supply of lava flows that flow pretty much directly to the ocean. And what happens is as the lava flows into the cold water, again, it cools almost instantaneously. And that cold lava it shatters into fragments, and sometimes these fragments can be sand size, sometimes they're larger, sometimes smaller, and so forth. But if you have a big enough lava flow, you can create a black sand beach almost instantaneously, geologically speaking. And so that's why there's so many of these in Iceland. And the same goes for many places in Hawaii as well, for those of you that are familiar with that area. So these things are pretty short-lived, geologically speaking. What can happen over time if the source of the lava goes away, then a lot of the stuff gets, it's pretty dense, it gets washed out to shore, out to sea. But the other reason that you don't see a lot of this is that these black minerals that make up the black sand are really the softest minerals. They are the ones that break down the quickest out of all the rock forming minerals. And so they end up either breaking into really small particles and getting washed away or dissolving. And then we end up with just sort of the quartz and the feldspars and the lighter tan stuff that's left behind. So another outcome of all of this volcanic activity are the presence of geysers and hot springs in Iceland. That's not very surprising. This is a picture of the famous geyser. It's spelled with an I. And in fact, our word geyser comes from this formal name geyser in Iceland. These are the only exploding hot springs in all of Northern Europe, which I actually found was pretty surprising. But the way these form is that you have water, it's gonna be rainwater kind of seeping down through that porous lava rock or through fractures, and it gets down close to the magma chambers and it starts to heat up. And as it heats, it kind of migrates and it finds places where it can move upward. It's less dense now, right? And it's wanting to go up these sort of conduits or cracks in the rock. And if there's any kind of twists or turns or constrictions, then this water can become superheated. And by that, we mean it's actually at boiling temperature or above, but it's not vaporizing. So it's like just, boiling point ready to go, but it hasn't vaporized yet. Until it finds an area where it's a little less constricted, a little less pressure, and then it flashes to steam. And when it does that, all of the overlying water in this conduit gets pushed up, and you see kind of this little blurb or this bubble that comes up out of the geyser, and that releases even more pressure, and then the whole thing just explodes. It's just this amazing eruption that you see here. Now, a hot spring is a similar process, except for there are no constrictions, so the hot water is just kind of coming to the surface here. I will say that geyser, not that impressive for those of us that have spent a lot of time at Yellowstone. But I will say that Icelanders make a lot better use of their hot water than we do in the US. So, for example, the national pastime in Iceland, surprisingly, one of the biggest is actually swimming, or maybe more properly, is soaking. And so you can see this is called the Hot Springs River. It's a cold river, but it's actually being fed off by also a lot of hot springs. And so people go up there and soak. I will say I spent the coldest day of my life in this area, but that's a story for another time. This is the oldest pool in Iceland. It was built in 1923, and it's all geothermal water. There are pools built like this in every town, village, and even out in the middle of nowhere in Iceland. Swimming is so popular. And then many of you have seen pictures of the Blue Lagoon, which is not a natural feature, by the way. This is actually geothermal wastewater from a plant that they poured into this enormous lagoon. It's become quite a tourist hotspot. Something I think is worth doing once for everyone. And the other benefit is that they use all of this hot water and steam to heat their greenhouses. They have greenhouses everywhere in the country, and this supplies the people of Iceland with all of their fresh vegetables and fruits, many fruits, not usually tree fruits, but also a lot of flowers. And there's greenhouses all over the countryside. And this one is one of my favorites. It's called Friedheimer Farm. And they have these greenhouses there, and their specialty are tomatoes. And we get to go there, and they'll give us a tour of the greenhouse, and they'll talk about how they grow everything, and they actually import their own bees, which is cool. And the bees are just kind of flying around in there in the greenhouse. And then you get to have this lunch right there among the tomatoes. And they're famous, of course, for their tomato soup. And they make this beautiful, like, homemade, all these kinds of breads and cheeses and, different kinds of fresh, mint sauces and stuff like that. It's just wonderful. And really great Bloody Marys as well, as you might expect. And so it's really one of our favorite stops on this trip. But probably the most important thing that Iceland does with all of that heat is using it for geothermal energy. And you can see here, I'm going to speed up a little bit. I'm sorry, because we're running a little bit short on time. Christoph, you might want to interrupt me at some point. But Iceland gets most of its energy from renewable sources, very little coal and oil, much of its energy from geothermal, and some from hydropower. And this is a pretty good way, a clean way of producing energy, relatively speaking. So water is pumped under the ground, it's heated, and then the steam is used to turn turbines to generate electricity. And also the hot water from this plant is pumped into pipes and sent to Reykjavik and other nearby towns, I should say. It hardly loses any heat on the way, which is amazing to me, but it flows under the streets and into the houses in Reykjavik, and it provides all of their heating. And it also means that they don't have to do any shoveling of snow in the winter because the streets are all heated. So the other really cool thing that this place is doing is they have been researching carbon capture. So there's a tiny little bit of carbon emissions that come out of this plant. And what they've been doing is pumping it back into the ground and mixing it with water, pumping it back into the ground to form carbonate minerals, which capture that CO2. And they've been really successful with doing this. They found that they have the mineral growth in like 2 to 3 years, which is much quicker than they expected. And it's really sort of a model for what we could be thinking about in terms of carbon capture in other places in the world. Again, I want to get back to kind of the concept of water in Iceland and water and rock. And so all of these lava flows form this really hard, what we call cap rock, which the water can often flow over. And when it does so, if there's softer rock sitting underneath, then it actually kind of erodes out that softer rock, and you get all these amazing waterfalls in Iceland. In Iceland, there's not a ton of sedimentary rock, so often this softer rock is something called pelagonite, which is a type of volcanic rock that's a little bit softer than the basalts. So you can see a really good example of this at Seljalandsfoss. This is one of the famous Icelandic waterfalls, but there's actually several you can see. This is actually an ancient sea coast, a sea cliff that you can see here. When the land was covered with ice, this whole area was depressed and closer to sea level here. But what you see here is the water flowing over the more resistant rock into this plunge pool, and it's been eroding out this softer rock underneath. And you can actually kind of walk back behind this so that you get totally soaked, but it's a pretty cool experience. Another example of this is at Foss. By the way, Foss means waterfall, so there's a lot of Foss things in Iceland. This is sort of a smaller scale. You can see kind of these layers of rock here. But what's really causing these big steps in this particular waterfall is the presence of these faults here, where there's a down drop block that kind of forms those steps. This is Hraunfossar. So Hraun means lava, so literally lava falls. Although what we're actually looking at is more of a spring. This is a case where you have water that's kind of flowing down through either porous or fractured basalts. It hits a layer that it can't move through, and so it finds the nearest exit and it comes out the side. And so that's what you're seeing in this waterfall here. And then I had to throw this in because I keep saying this, but this is also my favorite place in Iceland. And my family's favorite place is actually the picture that you see hanging on the wall behind me. This is a place called Gown Gorge, and I would call it fairyland. But you're out there driving along this really stark volcanic plain, and then all of a sudden, out of nowhere, there's this enormous gorge, which has got these waterfalls and springs, and you can see those columnar basalts that are all crazy shaped, and turquoise water, and there's caves and flowers everywhere. It is just a special place. You know, it's a little bit off the beaten path, and in fact, we got a flat tire last time we went there, but because the roads aren't paved and so forth. But it's totally worth it. And Icelanders, they believe in trolls. A lot of people do, and fairies. And if there was any place that had trolls and fairies, I'm pretty sure this would be it. Okay, I do need to mention hydroelectric energy, because with all that flowing water, you also have the potential for hydropower. It seems like a really clean way to generate energy. There's low CO2 emissions. There's no net water loss. Water flows in, water flows out. You can manage water in terms of flooding and providing, you know, agriculture, water, so forth. But there are a lot of issues with hydroelectric energy in Iceland, well, everywhere, but some of these are the fact that it damages really valuable wildlife habitat. It degrades the water quality. It decreases the amount of sediment that's transported downstream, which again has impact on the habitats. And in Iceland, the biggest problem is that they didn't need this energy. So they already produce more energy than the country needs. And so this hydroelectric sort of was an opportunity that came along with the opportunity for what we call heavy industry. So things that do pollute, like fertilizing plants, cement plants, silicon plants, those kinds of things. And so there's been a lot of controversy about, you know, why are they building these hydroelectric plants to supply energy when the energy is just going to promote these industries that aren't very environmentally sound. Okay, so we need to talk, we talked a lot about fire. We got to talk about the ice a little bit here, land of fire and ice. How am I doing on time? Oh, we're getting close. Christoph, do I need to skip a few? I don't know.
Well, we have still everyone in the room. Nobody has left. So I think we can go for a few more minutes, and then we'll wrap it up with a question and answer time.
Okay, sounds good. Okay, so here's a map of Iceland again. And you can see that all these white areas are the ice sheets, and most of them are concentrated in the southern part of the island. And there's a reason for this. And so here's Iceland again. And despite its name, and despite the fact that it sits so close to the Arctic Circle, it's actually has a much more mild climate than you might expect. And the reason for this is that we have these relatively warm Gulf currents that are coming up and flowing along the southern and western part of the island. So these warm currents are coming up, they're moderating the temperature a little bit, the air temperature as well as the water temperature, of course. But then what also is happening is that you have this cold Arctic air that's coming down from the north. And so you get the convergence of those two here in Iceland. And so the result of that is that you have just kind of a wild, highly variable climate condition, lots of storminess, lots of precipitation. And in the southern part of the island, this is where most of the tall mountains are. And so they tend to capture a lot of that precipitation and store that as snow in the glaciers. So there's also been ice, of course, over the geologic time. So again, the island itself is the oldest rocks are about 18 million years old. And this is a depiction of the island over the last 5 million years. What you see here, these black lines are actually the position of the ridge as it migrates. This is the ice in the white, and then the R is position where Reykjavik is today. And so you can see over time that the ridge is migrating. That's where it starts to splinter. And we had the development of these ice sheets. And the ice sheets hit their maximum basically during the last glacial maximum, which was about 20,000 years ago. The entire island was covered with ice. Pretty much since that time, glaciers have been disappearing from Iceland. With the exception of some little short cold intervals that we'll talk about in a second. But there are still some glaciers present, as we saw on the map there. One of these is Heimaeyjar. This is also, that means a sun glacier, basically. This is a picture of people standing at the base of it, and it's just this gorgeous, dark, deep blue, turquoise blue ice with all this black stuff that you see streaking through there is ash from eruptions. And so there's an eruption in Iceland like every 4 to 6 years. So you can pretty much go along here and detail all of these eruptions and the ash layers. Somebody will probably ask, I'm just going to go ahead and address it now. Why is the ice blue? Well, it has to do with the fact when you build up glacier ice, you pack it down so densely. Everything is just so tightly packed together that when light hits it, all of the wavelengths of the visible spectrum are absorbed except for those in the blue wavelengths. And so those get reflected back, and that's what we see in the ice. Now, it's really ephemeral. Like, this color does not stick around for long, because as soon as this ice is exposed to air, like it is here, it starts to refreeze, recrystallize. You get all these facets, and they begin to reflect back the rest of the spectrum. And so this will eventually all look white as it gets more exposure to air. This is our little intrepid Go Learn trip. I think this was in 2018. We went up on the ice with crampons and ice axes, and it was actually surprisingly harder than I thought it would be. We had a couple people fall, and it was challenging, and I thought I was going to have all these complaints and that they were going to call Christoph and say that was the worst thing ever, but it turned out this was people's favorite part of the trip. It was really fun. So another remnant of this glacial retreat is Jökulsárlón, which literally translates to glacial river lagoon. And you can see it here. This place is spectacular. All this beautiful water, again, the blue ice and the ash layers. This is the glacier in the background that is feeding this. So this, I'm going to show you this diagram, and I'm sorry about the quality. One of these days I'm going to recolor this. I'm trying to move my controls out of the way here. But you can see in these diagrams, starting down in the bottom, this glacier has been receding for about the last 100 years, 120 years. So this yellow is the land, and then down here at the bottom is the North Atlantic Ocean. And then here's the glacier. And you can see in 1900, it's almost to the ocean. In 1945, it's starting to pull back, and you can see the lake starting to form here. 1965, the lake's even bigger. And then I can't see this because I've got something in front of it. 1980, we have this larger lagoon here, in the glaciers even further back. I mean, if we had, the glacier ice is probably back a little bit further now. So a couple things to note is really looking at the presence of this channel right here. So keep an eye on where that is. I do want to say this Jökulsárlón is, I think if I remember right, check my notes really quick. Yeah, so it's super deep. So it actually goes to a little over 800 feet below sea level, and keep in mind the sea is right there. So that's pretty fascinating. So it's kind of a mix of fresh water, but there's a little bit of saline water that comes in with the tide as well. And so what happens is when the tide's coming in, all of this water, and I can't really see that in here, but there are dolphins, or not dolphins, seals that pop up everywhere, and it's just really fun to watch. So there's the channel, and then, whoops, having a hard time. There we go. Here's the channel in real life in picture. This was a couple years ago, I believe. And when the tide is going out, water's flowing from the lagoon down the channel under this bridge, and all these icebergs start cruising along down this channel. and they get washed out to the ocean and tumbled around by the waves, and then redeposited, polished up and redeposited on these black sand beach right here. And looks like diamonds. And so they call this the Diamond Beach. And it's really an impressive place. You know, when we're there in the summer, they're not quite as much of this, but it's still laying around on the beaches there. And we, again, with Go Learn, we like to have a nice time. So we're having a little toast to the diamonds on Diamond Beach on one of the sunny days that we were there. So I want to finish this off today with telling you a story about that ties all of this together. So everything from Vikings to glaciers to deforestation, climate change, and the world's yuckiest foods. So you'll find out what that means in a minute. So you will recall at the very beginning when we talked about the Viking settlers that when they arrived, there was plenty of forest on the island. About 40% of the island was trees. And so they cut down those trees and they built these really long, what we would think of as a traditional wooden Viking longhouse. These were big houses, lots of different people, the workers and all kinds of people, not just the family, lived in these longhouses that eventually got covered with turf. These are sort of storage rooms, and in one case, even sort of a bathroom in the back of this. But these were pretty common in early parts of in early times in Iceland. And then over time, you start to see the appearance of these smaller turf houses and the disappearance of the long wooden longhouses. And so there's a reason for this. And it's not just because they deforested the country and there's hardly any trees left, but turf houses are much smaller and they don't take as much to heat. And what was happening is that the climate was actually getting colder, which necessitated the building of these smaller houses. So this is a graph of temperature changes in the Northern Hemisphere over the last 10,000 years. And the axes are kind of a little bit wonky, so don't worry about that too much, but just know that red means warm and blue means colder, and present is right here on the right-hand side of the graph. So you can see that there was a big period of time where things were mostly warm, with these little periods of time where there's cold and glaciations, and this all corresponds with global glacial events. There's a big cold period of time right before the Vikings first settle in Iceland. So when they get there, this is probably because the harbors have, or not the harbors, but the bays have opened up and so forth, which allowed them to explore these places and settle them. Things are starting to get warm there. So this is a period of time called the medieval warming, and they stayed warm there for about 300 years. So that was about the time it took them to cut down all the trees. So, but about sometime in the 14th century, roughly, about year 1350 or so, things kind of take a turn for the colder. So this is a period of time called the Little Ice Age, and this occurred all over Northern Europe. And the temperature changes weren't that extreme, maybe about 1 degree C, but it was enough to disrupt the already really short growing period. And that caused a lot of problems in terms of food availability and so forth. It also caused the harbors to freeze over, and so they weren't able to bring food and supplies over from Norway or other places. And essentially the people really started to starve. So they had cows and sheep over there, but it turns out cows weren't a great livestock choice because they couldn't handle the colder temperatures, so they'd have to be brought inside. They also needed to be fed a lot of the barley that they used to make beer, and that barley was now needed to actually feed people and the other livestock like the sheep, who were much better suited for the climate. So cows were not really that practical at that period of time. So all of this led to the end of beef and beer in Iceland and the unfortunate rise of a whole bunch of really horrible things, because if you're starving, you're going to eat pretty much anything that you can get. And this included things like seal flippers, puffin, those cute little puffin, boiled sheep head, boiled sheep testicles, all really awful things. But the worst of which is probably this thing. It's called halkot. That's how that's pronounced, halkot. And it is essentially rotted shark. So you have to wonder, why in the world would they intentionally eat rotted shark? Well, there's actually a reason for that. The one thing that was abundant in the waters were these sharks that came over from Greenland. And but they had one major drawback, and that is that they were toxic to humans. So humans could not eat them without getting sick, caused all kinds of disorders and disease and so forth. So in order to deal with this, they would bury these pieces of shark in the dirt for a couple months and let them ferment. And as the meat was fermenting, it was pulling the urea out of the sharks. Sharks have a lot of urea. We expel it in our urine, but they have a lot of it because it helps kind of balance with the seawater. Anyway, so that urea is being pulled out of the shark meat and makes the meat pretty much smell like ammonia. So it smells like ammonia. I've heard it tastes like a really strong blue cheese that has an aftertaste of urine. So despite being a delicacy and a national food of Iceland, I have not tried it. But I just wanted to point out that now if you go, you know what to eat, which is the fresh vegetables out of the greenhouses, and also what not to eat, which is this halkot. Don't let anybody pressure you into it. It's kind of a macho thing to be able to choke this down. So the locals only eat it on occasion. And so with that, I want to say Thakka thea freri, which means thank you in Icelandic, or just thak. And if we have time, I'm happy to entertain any questions.
Thank you, thank you, thank you. What a great lecture on, well, just on Iceland, on geology. And I learned a lot. So, you know, I forgot my yogurt. It was probably one of the highlights. I told you to stop. I mean, you did stop on a good note, but that food,
Sorry about
shark,
that.
thank you very much. Ending with, now that won't leave my mind. So yes, we are losing a few people, but let's see if we can get to some of the questions really quick. Thank you, Holly, for taking us on this trip. Let me see. I'm scrolling down in the questions first. Here's a question. Iceland was an active volcanic system in the same general geographical. Well, hold on. If Iceland was an active volcanic system in the same general geographic location, perhaps if it was an arc system instead, and was comprised of more intermediate or felsic flows instead of the basalt, would the soil and foliage growth still be the same, or would it be more or less fertile for plants and animal life? I've always been interested in how geology affects the life that grows on it.
Well, I can attempt to answer that question. That's a lot of ifs to think about all at once. The soil is definitely going to have a different composition, and you know, the type of rocks. So the person obviously knows a bit about geology here when they're talking about intermediate and felsic flows instead of basalt. Basically, those are distinctions between the types of the composition of the lava itself, and it tells you how deep in the earth it actually came from. But they basically, those flows have different minerals in them, and different minerals are good for different kinds of plants. So I think that the foliage growth would probably be different. The soil, oh gosh, I'm just kind of speculating here. I think that if it was more felsic, it would probably be even a bigger challenge because there's fewer of those minerals that break down really quickly in that. And so that would be my guess.
Good. We did speak a little bit to microbes, but there was just a comment. I'm so excited. I hope there's some information about unique microbes in the country.
if there's some information, is that what the question was?
Well, it was basically, do you have some information on that?
Oh, other than to say that there are some, I'm not really an expert on microbes, but again, like with Surtsey, that's a place where they're really kind of looking at what these things look like when they first colonize on a land. There's probably a lot of really unique microorganisms in some of those hot springs. These are really some extreme environments. And so there's probably all kinds of things that are new or unique to the Iceland environment as well.
I did like the that you pointed out with this new island and how it's being studied. And I think that's very much part of that study as well, how those microbes get a foothold and then start life in what was a few hundred or 1,000 years ago, just rock or lava.
Yeah, I think that's pretty cool. Yeah.
Somebody asked if we can address the economic recovery after 2008 financial crisis.
Mm-hmm.
Yes, Iceland was hit pretty hard. It was a tax haven within Europe and was victim to the financial crisis in 2007 and 8. Do you have any information on that when you were visiting? What were people saying?
So this is where the Eyjafjallajökull really impacts this story, because again, with that eruption, that changed the entire economy in Iceland. So that eruption and the subsequent tourism that it spurred really served to bring the country out of that economic downturn. And so they really welcomed all that tourism with open arms, but like I said, has had a lot of other kinds of impacts on the land that are still a big problem there as well.
And then in terms of recovery, we know it's 364,000 people. So it's like a much smaller populace to recover. But also I do know that Iceland, if it's not the only, but one of the only countries where bankers were actually put in jail. So 26 of them were actually sentenced to various prison time in their doing during the financial crisis and in masking and fraudulent transactions. The other thing that's really interesting is 5% of Icelandic people are Polish. And that's all this boom. They needed a lot of construction workers, and within Europe, that was sort of like your labor market of the day. And a lot of Polish have settled in Iceland now.
Yeah,
it's the second language. It's the second spoken language on the island, Polish.
Yeah, we've met quite a few Poles when we're over there as well. It's super interesting though about that whole infrastructure and all the construction and everything. So you drive around Iceland and there are cranes everywhere, but they're not moving. And they've had a really hard time. Like they'll get the equipment there, but then they don't have the workers to run it. And so it's just been kind of a mess, just a scramble to try to keep up with all this growth and try to still keep the country as pristine as possible. Again, I mentioned I was so grateful to be traveling with Go Learn in these small groups, because these big tour buses would pull up with 100 people, or the cruise ships or whatever, and it was just moving around in these masses of people, where we were really able to go sort of off the beaten path. But it also makes it challenging when you're off the beaten path in a place that doesn't have a lot of infrastructure. Where do you eat and where do you sleep? So all that kind of stuff. So
I mean, we do plan to return to Iceland. At this point, it would be July 15 to 24 next year. That's part of the challenges that we're having right now. In the crisis, they completely shut down. And it is really hard to get in with hotels. It's really hard to book these hotels. And because they're so spoiled by an annual growth of 20% in the last 3 years, every year, 20% more people came to the island. That's kind of like a job security in the tourism industry. And that also makes it really hard for someone who comes with a group. So our groups are small by design, and that helps us in this regard. And so, yes, it's even for individuals, it's really hard to plan a trip to Iceland. So you have to think about a year in advance at least.
Mm-hmm. Mm-hmm.
Yeah. Someone made a comment. Thank you so much for this geology lesson, Dr. Godsey. we visited Iceland in a couple of years ago, but missed out on so many of these geological wonders. That's Go Learn. Just to let you know, we're not just saying, hey, somebody build us a trip and we're putting Holly on this trip and then Holly will just fill in. This is a trip with Go Learn that you invented, that you created. And that's based on the places that you would like for us to see and show us. And I think that makes it also very unique to travel with Go Learn at any faculty, because it's our faculty for most parts who built these trips and help us see what it is that we want to learn. So thank you, Holly. Mm-hmm. Lots of comments in terms of positive, like, thank you, this was great, very interesting. Thank you, loved it so much. There's Lisa, Heather, Barbara, Suzanne. Yeah, a bunch of people saying thank you very much. Okay, here's one technical question. Where is another mid-ocean ridge visible? I think you answered it, but is there one?
Well, so the Mid-Atlantic Ridge, there are places where it does pop up in little islands, for example, off the coast of Portugal. So little places like that, but you're not really where you can see the evidence of the rifting or the spreading apart, but just in those cases, little sort of mountain spires that form little islands in the ocean. But they're very rare and very small, and I think that Iceland is very unique in that respect.
Is it the only place on the planet where you can actually touch and see two tectonic?
Yes, as far, well, on dry land.
On dry land. You
That's
could go down in the ocean.
Right there. Yeah.
Okay.
Yeah. So those spreading centers occur mostly in really deep parts of the ocean. So yes, in terms of being able to put a hand on one plate and a hand on another, although it's quite like that, you have to have really long arms, but except for in that sulfur trench there, it's really one of the only place that I know of where you can do that. So it's pretty cool. It's way cooler than like the four corners of Utah, like putting a hand and a foot and
well, that's cool too, but yeah, it's not a geological, it's a man-made boundary versus a nature, a feature of nature. Let's see, have you watched Eurovision, a new release on Netflix? If so, would you say the characters accurately portray Icelanders? I have not seen this.
I haven't seen it, so I can't really address that.
What I do know about them, and you mentioned a little bit, fairies and trolls play a pretty big cultural role. Mm-hmm. And maybe it goes back to the origins of Icelandics, the Norsemen and the myths. And like you said, these big sagas play a major role in how Icelandic people see themselves. But it's definitely an interesting culture.
It is. And, all the kids learn the sagas in school. And as you're traveling on that landscape, the light is always doing crazy things because, you're so far north and you've got these super long days in the summer and, really short days in the winter and the lights in the clouds. I mean, it's just, then you've got all these lava landscapes covered with moss and all these things start playing tricks on your eyes. And for those of you that have seen Frozen, there's this scene where these little boulder trolls or whatever, they're like all this moss valley and they're these boulder lumps and then they roll and all of a sudden they're these trolls. You can totally see that happening in Iceland. If there is a place these things exist, it's going to be there. That's for sure.
Uh-huh. All right, I'm trying to get to the later this. Lots of things here. Again, there's a Heather, Elisa, and Barbara I mentioned already. With all the volcanic activities, have there been any major recent earthquakes in Iceland? It shakes all the time, right?
Yes, it pretty much continuously. So the person obviously knows a little bit about geology that asked the question. And when you've got really hot molten stuff moving underground, you're going to shake the earth, you're going to crack it, fracture it, move it. And so, earthquakes occur mainly where all these volcanoes are occurring, but they can occur anywhere across the country.
And Neil made a comment. You mentioned grabens before. Yeah, hi, Neil. He was one of our participants.
Yes.
Neil said an example of a graben is over where Lakai restaurant is, just south of Big Cottonwood, I think it is.
Yeah. So it's at the base of Little Cottonwood.
Little
For those of you that are from Salt Lake, for those of you that are not, this won't mean anything, but there's the road that runs in front of the Lakai restaurant, which is a pretty fancy restaurant, but it kind of drops down into this valley and then comes back out. And that is bounded on both sides by normal faults, which means the block in the middle was just dropped down relative to the sides. And so that's a little sort of miniature graben right there. He is absolutely correct.
And Neil's wife, Gloria, says hi as well.
Oh, hi, Gloria. And Alexis, if she's around.
What about something, and here's Neil again, what about San Andreas Fault, where two plates slide by each other? You mentioned that. Yeah, I think we talked about it.
Yeah. There are, that's called a transform fault. There are transform faults that occur in the region. There's transform faults all up and down the sort of perpendicular to the ridge axis, because there have to be places, the ridge doesn't spread all at once at the same time. So different pieces break off and those plates will slide past each other in places. And so there's transform faults like the San Andreas pretty much all over the place.
Wow. Well, I think we got through them all. Just another comment on the actors on Eurovision, how they're not Icelanders, but I think we all have to first see Eurovision so we can talk about it. I don't know exactly what that is. So
yeah, I don't either, but I'm interested now. So.
Yeah. Okay, the room is still a little bit of half full. We still have over 50 people, almost 60 people here. I just want to point out one more time. Also, another thing, we are going to New Zealand next year. The dates have still been a little bit shaky and we'll have to organize this, but Holly will take us to another crazy island. And again, it's with this pandemic, both of them are just like what islands can do. They can shut themselves off to the rest of the world. So we'll see if we can travel there. So stay tuned, everyone who might be interested to travel with Holly, because as you can tell, it would be very special. I think we're through with questions, and again, a lot of people say thank you, and let me be one of them. Thank you so much. Again, this is brought for free to you guys, pro bono. So thanks for your time and sharing your passion about Iceland. No doubt one of the most interesting places on the planet with us, and I can't thank you enough. It was wonderful to have you.
Well, thanks for having me. It's been really fun, and I am dying to go back.
We all are. I'm just, only on Thursdays for these webinars can I come in here and I look at all of our artwork of our places that we usually would go right now, and it's definitely itching and it's hurting. So
yeah, I'm sure. But well, thank you.
Good. All right. Thank you, everyone out there. And I'll see you next Thursday for the next presentation. If you're interested, so go to golearn.utah.edu and see what's coming up. All right. Thank you. Thank you, Holly.